Student, here we are going to see about the rectification of signal. Sinusoidal, we are going to rectify the signal will be less than 0.7 volt. Here we are going to supply the input, and this input will amplify, this opamp will amplify the input. We are going to give the input less than 0.7. It is going to amplify by the open loop gain, and then it is going to rectify. And here we are going to feedback to negative terminal, and across this resistance we are going to take the output. Now if we look at the circuit, now this is your circuit. What I did in the circuit, if you look at the circuit, this is your op-amp. From here I have taken, from terminal 6 I have taken the diode, and this is where we have connected to ground. From here we are taking the output. This is the wire to take the output. Here we are taking the output. Here we are going to take the output, and here this is the wire which has been connected to terminal 2, and here the input has been connected to terminal 3. If we look at the DSO, see, this is your yellow one is the input that we have supplied. This is the input we have supplied, and if you see the peak to peak value of channel 2. Now if you see we have given 576 volt. It means it is lesser than the input we have given 576 volt. It means it is millivolt. It is lesser than 0.7 volt, and output we are getting 304, means half of this input we are getting the output. Now this is in millivolt, less than 0.7 volt, and then also it is rectifying. This is your input, yellow one is the input, and if you see the output, this is the rectified output. We are getting the rectifier output. Now this is value less than 0.7 volt. If we increase the input, now we are increasing the input, then also it is doing the rectification. Now we have made to 1.10 peak to peak. Now if you again move greater than, now if I applied the signal 0.8, the signal is 0.8 sin omega t, and this is your frequency, 250 Hz frequency. This is peak to peak, means I have applied the input which is greater than 0.8. Now I am getting the signal around the 0.4. Now if I decrease the input, then also it is amplifying. It can amplify a value lesser than 0.7 volt. Now this has been shown here. Now suppose this is the input. Now suppose if I change the diode connection, this is your diode connection. Now if I change the reverse the diode connection, then our rectification must get reverse. This is where I am connecting the diode. I am making a reverse connection. If you look at the output, you are getting the rectified output in reverse. Now I have to change the level so that it will come to stable mode. Trigger level so that it will come to stable mode. Now this is your input. This is your input. Now this input has been, if you make to same level, this is has been rectified in negative direction. See, this is your negative value half wave rectification. Now if you see the channel 1 input, this is 592 millivolt. If you have around 300 millivolt signal we are giving, and we are getting around 144 millivolt signal we are going to get at the rate of 250 Hz. So it is rectifying the signal which is lesser than your 0.7 volt. So this was all about your half wave rectification.